Hello students, myself Dr. Pranay Magdum, and we have already started with the particle physics. So in previous videos we have seen the classification of the fundamental forces, then we have also seen the classification of the elementary particles, and we have also dealt with the quantum numbers of these elementary particles. And today we are going to see the concept of the Cork model. Now this Cork model was proposed by Gell-Mann and Nishijima, and they have put forth the two postulates which says that these baryons are made up of three quarks and mesons are made up of one quark and one anti-quark. So in my previous video we have seen that the elementary particles can be classified as the leptons and the hardons. The leptons which take part in a weak interaction, whereas the hardons which are the particles which take part in a strong interaction. Now these hardons are again classified into the mesons and the baryons. So the mesons are less particles of the medium weight, and the baryons are the heavier particles with a spin 1/2. These mesons have the spin is equal to 0, spin is 0 particles, and these baryons are the spin half particles. So well-known example of the baryon is a proton and a neutron. We know that these are the spin half particles, and the well-known example of the baryon is a pions, kaons and eta. So all these are the spin 0 particles. Okay. Now according to this Cork model put forth by Gell-Mann and Nishijima, they say that these baryons are made up of three quarks. So how these quarks make these baryons, this also we have seen in my previous video. If you want to check how these baryons are made up of different quarks, so if you want to know how the quarks make these baryons or how these are constituting parts for the baryons, you can watch my previous video. I will put a link into the description box. You can go, and there I have solved many examples of the baryons and the pions and how quarks make the different baryons and different mesons. Okay. Now these baryons are made up of three quarks, whereas the mesons are made up of one quark and one anti-quark. Now the Cork model is the model to suggest that in a large number of the particles there must be some similarity, or these particles are made with the help of some rules. Like whenever there is a repetition, scientists come to know that there must be some similarity into this large number of the particles. So the Cork model suggests us arrangement of these different types of the particles in a one diagram. Okay, so this Cork model binds large number of the elementary particles in one diagram. Okay, so whenever there is a repeatability, so we say that there must be some rule hidden, the natural rule somewhere it must be hidden. Okay, now see here, so the Cork model has different models. So we can, one of them is a meson octet. Okay, so this Cork model is made up of horizontal lines. So horizontal lines suggest the strangeness. I'll write it here, where S represents the strangeness. Now you already know that strangeness is a quantum number. That also we have seen in my previous video. Okay, so horizontal lines represents the strangeness. Okay, and these diagonal lines represents the charge of the particle. Okay, now we know that mesons are pions, kaons and eta particles are also there. Okay, here in this figure eta is not shown yet. Okay, as there are 8 particles, it is called as a meson octet, and all of them are mesons, so it is called as a meson octet. Okay, now here from this figure we can see that, so this strangeness is equal to 1 for k plus and k0. So the strangeness is 0, we have already seen, for pi minus, pi 0 and pi plus, and strangeness is -1 for the k minus and k0, anti-k0 particle. Okay, and the charge for these two particles K plus and pi plus is +1. For this K0, pi 0 and anti-K0 it is a 0, and for this pi minus and K minus the charge is -1. So this diagram is suggesting us in a large number of particles with a there must be some rule should be there so as to construct these particles by using the different quarks. Okay, just like a periodic table. Okay, so just like a periodic table, in the periodic table large number of elements are there, but the constituent atom for all elements is protons, neutrons and electrons. So different combinations of protons, neutrons and electrons will make the different particle. Similarly, different combinations of these quarks will make the different particles. Okay, now quarks are only of three types, like up quark, down quark and strange quark. I'll write it here. So up quark is there, down quark is there and strange quark is there. So here I have drawn the three basic quarks as down quark, up quark and a strange quark. Only three quarks are there and their antiparticles like anti-up quark, anti-down quark and anti-strange quark. Okay, so this down quark and this up quark has a strangeness 0. These are strange-less particles. Okay, and this strange quark, it is having strange of -1. So the charge on the up quark is 2 by 3 and the charge on a down quark and a strange quark it is -1 by 3. Fractional charges are not yet found actually. Okay, so only three types of the quarks make all the different numbers of all the large number of the particles in the universe. Okay, and this is how we concluded that there must be only three quarks. Okay, by using this diagram. Okay, so Gell-Mann-Nishijima put forth that these diagrams are showing some similarity in a large number of particles. Few rules are being followed. Okay, and from that we concluded that there must be a Cork model. There must be some constituent elementary particles which are constructing the different particles. Okay, now here is another diagram which is called as a, yes, I forgot to tell you that. So meson octet or a meson nonate it is said. Okay, so octet it is called as octet because there are 8 particles, but sometimes it is called as a nonate. So when you call it as a nonate, afterward, so eta and eta prime. Okay, so we also know that the mesons are of k, pi and eta. So eta is also one of the meson. So first this eta was not found, and afterwards when it was found they came to know that the meson nonate. It came to know that meson has a 9 particles. Okay, now one more diagram is given over here which says is a baryon octet. Now we know that these baryons are the spin half particles. These mesons are the spin less particles. The spin is a 0. So these are behaving like bosons. Write it here. Whether these are the fermions. Spin half particles. So these are the fermions. Okay, they follow the Pauli's exclusion principle, whereas these doesn't. Okay. So baryon octet, so we know that there are different baryons like protons, neutrons, sigma minus, sigma 0, sigma plus and the cascade. Okay, now as we have discussed previously, so this horizontal lines gives us the strangeness and this diagonal lines represents the charge. Okay, now the strangeness for the neutron and proton is 0, for a sigma minus, sigma 0 and sigma plus, the strangeness is -1 and the strangeness is equal to -2 for the cascades. Okay, and the charges are given on these lines. Similarly, so baryon decaplet, which is having these are the particles which are having the spin is equal to 3 by 2, and this is a triangular shape is given over here, and they found that there are 4 lambda baryons, then 3 sigma baryons, then 2 cascade baryons, and in a triangular shape there was nothing found which was having, so this is strangeness is equal to -3 and charge is equal to -1. So afterwards, so this omega particle with a minus charge and which was having the strangeness is equal to -3. So it is made up of S and S particle. So this is the constituent of this omega minus. So this Cork model also helped to find or theoretically imagination of the few particles, and these particles were afterwards found. Okay, so this baryon omega, first it was proposed theoretically by using this Cork model, and then afterwards it was confirmed experimentally. So by using this Cork model, we can theoretically evaluate the strangeness or charge on any meson or a baryon. Thank you for watching.